Astronomers once imagined the universe as a vast sea of galaxies, but modern observations revealed something far stranger. Most of the cosmos is actually empty. Enormous regions called cosmic voids dominate the universe's structure, stretching across hundreds of millions of light years. For decades, they were treated as passive gaps between galaxies. Yet new research and simulations suggest these silent regions are anything but passive. They expand, merge, and may reveal the clearest evidence of dark energy shaping the universe. In this video, we'll explore how scientists uncovered this hidden architecture, how they study these enormous voids, and why the emptiest places in space may determine the universe's future. The first key realization about cosmic voids is that the universe is not randomly filled with galaxies. Instead, it resembles a gigantic three-dimensional network known as the cosmic web. Large galaxy surveys, such as the Sloan Digital Sky Survey and the 2DF Galaxy Redshift Survey, mapped millions of galaxies across space. When astronomers visualized this data, they discovered something astonishing. Galaxies gather along enormous filaments and walls, leaving behind vast bubbles of near-empty space. These bubbles are the cosmic voids. Observations show that many of these voids are enormous structures. Some measure more than 300 million light-years across, making them among the largest features in the known universe. Rather than isolated gaps, they form a foam-like pattern where galaxies sit along the thin edges while the interior remains extremely sparse. This structure matches predictions from cosmological simulations that model how matter evolved after the Big Bang. The reason these voids exist lies in the early universe. Shortly after the Big Bang, matter was almost evenly distributed, but contained tiny density fluctuations. Regions that were slightly denser began pulling in surrounding matter through gravity. Over billions of years, those regions grew into the clusters and filaments of galaxies we observe today. Meanwhile, areas that started slightly less dense lost material to their surroundings. As matter drained away, these regions expanded and became the cosmic voids. Computer simulations confirm this behavior in remarkable detail. When physicists model the growth of the universe using dark matter and gravity, they consistently see the same pattern emerge: dense filaments forming a web while huge empty bubbles grow between them. Matter flows outward from void centers towards surrounding structures, creating what researchers sometimes describe as a cosmic drainage system. This means voids are not static holes in space. They are dynamic environments where matter is constantly moving outward. As galaxies migrate toward filaments and clusters, the interior of each void becomes increasingly empty. Over time, neighboring voids may even merge, forming larger bubbles that reshape the surrounding galaxy distribution. Understanding this large-scale structure changed how scientists view the universe. Instead of focusing only on galaxies and clusters, researchers realized that the emptiest regions play a crucial role in shaping everything else. But this raises a deeper puzzle. If gravity pulls matter into dense areas, what mechanism allows these giant bubbles to keep expanding? The answer points toward one of the biggest mysteries in modern physics. The next discovery about cosmic voids revealed something far more profound. They may be one of the best places to study dark energy. To understand why, scientists turn to fundamental physics describing empty space itself. According to quantum field theory, even a perfect vacuum is not truly empty. The Heisenberg uncertainty principle predicts tiny fluctuations of energy appearing and disappearing throughout space. These fluctuations give rise to a subtle background energy known as vacuum energy. In cosmology, vacuum energy is closely connected to the phenomenon called dark energy. In 1998, astronomers studying distant Type 1a supernovae discovered that the expansion of the universe is accelerating rather than slowing down. The most widely accepted explanation is that a mysterious energy permeates space and pushes the universe apart. This energy is now estimated to make up roughly 70% of the universe's total energy content. Dense regions like galaxy clusters are dominated by gravity. Their large mass creates a strong gravitational pull that partially counteracts cosmic expansion. But inside cosmic voids, the situation is very different. These regions contain very little matter, which means gravity has far less influence. As a result, the effects of cosmic expansion become more pronounced. Observations and simulations suggest that voids behave like expanding bubbles within the cosmic web. As the universe grows, the boundaries between voids move outward, pushing galaxies along filaments farther apart. Some researchers describe voids as the clearest laboratories for observing dark energy in action, because fewer astrophysical processes interfere with the measurement. This is also why cosmologists are increasingly using voids to test theoretical models of the universe. Because these regions contain fewer galaxies, less gas, and fewer energetic events such as supernova explosions, they provide a relatively clean environment for studying large-scale cosmic expansion. Scientists can measure how galaxies move around voids, how void boundaries shift over time, and how light traveling through them is affected by the universe's geometry. Another important implication emerges from these measurements. As cosmic expansion continues for billions of years, voids will gradually grow larger and merge with neighboring voids. The cosmic web will stretch and thin, leaving galaxies increasingly isolated from one another. In other words, the emptiest parts of the universe are quietly reshaping the entire cosmic landscape. But despite their apparent emptiness, voids are not completely devoid of matter. Hidden within them are some of the most unusual galaxies astronomers have ever observed. Although cosmic voids contain very little matter, astronomers have discovered that they are not entirely empty. Scattered within these vast regions are rare objects known as void galaxies. These galaxies exist in extreme isolation, far from the crowded environments where most galaxies evolve. Their existence surprised astronomers because conventional models once predicted that galaxy formation should be extremely rare in such low-density regions. Observational surveys have now identified hundreds of these galaxies residing deep inside voids. Many of them are smaller systems, such as dwarf galaxies or faint spirals. What makes them fascinating is the environment in which they evolve. Unlike galaxies in clusters or filaments, void galaxies rarely experience gravitational interactions with neighbors. They are largely free from collisions, mergers, and intense bursts of star formation triggered by nearby galaxies. This isolation leads to a very different evolutionary history. Studies show that void galaxies often evolve more slowly and maintain simpler structures compared with galaxies in crowded regions. Because they avoid violent interactions, they can preserve characteristics that resemble earlier stages of galaxy formation. In a sense, they act as cosmic time capsules, offering astronomers a glimpse into processes that occurred billions of years ago. Researchers study these galaxies carefully because they help answer fundamental questions about how galaxies form and grow. By comparing void galaxies with those in dense clusters, astronomers can isolate which properties come from internal processes and which are caused by environmental effects. This comparison allows scientists to refine models of galaxy formation and understand the role of dark matter in shaping galaxies. Another intriguing possibility involves the far future of the universe. As cosmic expansion accelerates, galaxies will drift farther apart. Over trillions of years, many galaxies outside local groups will move beyond the observable horizon. In that distant future, the universe may consist of isolated pockets of galaxies, separated by enormous expanses of darkness. In such a scenario, void galaxies could represent some of the quietest surviving regions of cosmic history, evolving slowly while the rest of the universe becomes increasingly diffuse. Studying them today may offer clues about what the universe might look like in the far future. What began as a simple attempt to map galaxy distributions has therefore led to a remarkable conclusion. The universe's structure is shaped not only by where matter gathers, but also by where it disappears. Cosmic voids once seemed like insignificant gaps between galaxies. Modern astronomy has revealed the opposite. These vast regions dominate the universe's volume, influence the distribution of galaxies, and provide one of the clearest windows into the mysterious force driving cosmic expansion. By studying how voids grow and how galaxies behave within them, scientists gain valuable insight into dark energy, galaxy evolution, and the future structure of the universe. So here's the real question. If the emptiest regions of space are shaping the structure and expansion of the cosmos, could the ultimate fate of the universe actually be written in these vast cosmic voids? Drop your thoughts in the comments. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.